Hello, Mr. Burke. This is my multi-particle momentum principle screencast. I'm answering the question, how do we know that the change in momentum of the system is just the sum of all the external forces acting on an object multiplied by the time of interaction? The really simple answer, one-word answer, is reciprocity, and I don't think I pronounced that right. But essentially, because of the reciprocity principle, internal forces cancel each other out, leaving only the external forces that affect the total change in momentum of the system. Anyway, let's go see how exactly that comes to be through looking at the actual equations. So starting off, some simple definitions. External means exerted on an object by the surroundings. Internal means exerted on an object in the system by other objects also in the system. So we start off with using the momentum principle to define the momentum of a system. The total change in momentum of a system is the final momentum of the system minus the initial momentum of the system, and this is equal to F net times change in t. Now F net is equal to the sum of all the external forces on a system, and the momentum of a system is equal to all of the momentums of individual objects within the system. Anyway, this is all about why it's interesting. Essentially, it's interesting because if we take this to be true, what it means is that we don't need to understand the internal forces inside a system to understand the total motion of the system. If all we know the external forces acting on a system, we can understand the system's total change in momentum, we can understand the system's total change in motion. Anyway, very interesting. But on to why do internal forces cancel? Well, first what we do is we're going to look at this example right here. So all the forces acting on the particles are shown. Lowercase f's are internal forces between particles that the particles exert on each other. And the upper forces, the uppercase f's are forces exerted on the objects in the system by the surroundings. So that's why they're called external forces. Anyway, so first what we do is we define going back to this, we're defining the change in momentum of all the individual objects. So the change in momentum of particle 1, where do we go? Particle 1 is the force of the surroundings on 1 plus the internal force of object 2 on object 1 plus the internal force of object 3 on object 1. And this is all times change in t. And then same thing for change in momentum of object 2. Its total change in momentum is equal to the external force of the surroundings on 2 plus the internal force of 1 on 2 plus the internal force of object 3 on object 2. All times change, and same thing for object 3. Anyway, here's where it gets interesting, because now we add up these three equations. Essentially, we're just going to add P1 plus P2 plus P3 on one side, and then add F1 sir plus F12 plus F13 plus 2 plus 3, giving us this equation. So all of the change in momentums are on the left, and all of the forces are on the right. And this is where reciprocity comes in, because many of these terms cancel by the principle of reciprocity. Because as we can see up here, the force on object 1 by object 2 is equal to the negative force on object 2 by object 1 by reciprocity. I believe it's Newton's third law, but it might be another of Newton's laws. Either way. Anyway, so if the force on 1 by 2 is equal to negative of the force on 2 by 1, we can cancel out this with this, and this with this, and this with this, leaving us only change in P1 plus change in P2 plus change in P3 equals the force of the surroundings on 1 plus the surroundings on 2 plus the surroundings on 3, all times change in T. And this simplifies change in P1 plus change in P2 plus change in P3 to change in momentum of the system, and then this simplifies to the change, to the F net of the surroundings on the system times change in T. Anyway, ultimately, the importance of this is that the principle of reciprocity actually eliminates all the internal forces because all the internal forces cancel each other out. Thus, the internal forces can't affect the motion of the system as a whole, and if we want to be able to calculate to understand the motion of the system as a whole, all we need is the net external force on the system, which is very useful for physicists. Anyway, have a good evening. Thank you.